Hello everyone, this is a video lecture for vector addition. So vector addition is a method of adding vectors to determine the sum of vectors, also known as the resultant vector. So last time we were discussing about vector measurement, so wherein you were able to measure the magnitude and direction of one vector. This time we will combine two or more vectors and determine the magnitude and direction of the resultant vector. So in our previous examples, we have example 1 and 2. So a student walks 5 kilometers north, then walks 7 kilometers 60 degrees north of east, then stop. So question now is, where is the student from the starting point and how far is it from the starting point? So we are basically trying to determine the location of the student from the starting point in terms of how far is it and where is it with reference to the starting point. So there are two methods in getting the resultant vector. The graphical method, wherein we are basically going to plot vectors in the form of arrows. So if you have two or more arrows, we will have to combine to plot the two or more arrows and determine the resultant, just like this one. So the first ways of doing graphical method is the head to tail or triangle method. So wherein if we have vector 1 and we have vector 2, so basically head to tail or triangle method is from the word itself, head to tail. So the head of the first vector is connected to the tail of the next vector. So that's why it's called head to tail. And then the resultant vector is always from the starting point to the end point. So you are going to determine the magnitude and direction of the resultant vector. Next we have parallelogram method. So here you are going to plot the vectors concurrently, meaning they will have to start at the same starting point. So we have vector 1 and vector 2. So they started at the same starting point. So how do we do parallelogram method? Is first you are going to draw a line parallel to vector 1, which is this one, and then a line parallel to vector 2, which is this vector. So the point of intersection between vector 1 and vector 2, or this point, will be the end point of your resultant vector. So if you observe, our head to tail method and parallelogram method is just the same in terms of magnitude and direction of the resultant vector, but they do differ in how you plot the vectors. So that is for graphical method. So basically you are going to plot, and then in determining the resultant vector you are going to use ruler for the magnitude or the length of the arrow, and then for the angle you can use protractor. So the angle will give you the direction. So for the next method in getting the resultant vector is the analytical method. So this is the computation method. So we don't have to measure or plot and measure, but here we can plot and compute directly for the resultant vector. So there are two ways in doing analytical method. First one is the component method, which uses trigonometry, and the second one is the sine and cosine law method, which uses sine law and cosine law. So examples of the head to tail method. So if we have the same example as the one we started. So we have 5 kilometer north and then 7 kilometer 60 degrees north of east. So to plot that one on our x and y axis, so the first vector, which is 5, if you observe, it has to stop at 5. And then now, since in your bond paper you don't have these grid lines, you can have a scale of, since this is in kilometers, you can have 1 kilometer equals 1 centimeter, so that you can use your ruler. Because if we are going to plot the 5 kilometer on our bond paper, it cannot fit. So we just use a scale which is just proportionate to the actual given. Then the next vector is this one. So how do I know that this one is already 7 kilometers, or 7, in this case we have grid lines? So I use this one as a measuring tool. So these lines here, or the grid lines here, is just the same as the background grid lines in terms of length or in terms of intervals. So I just crop the background and put it there. So you have, if we count, this one is 1, 2, 3, 4, 5, 6, 7. So we have 7 kilometers, and the angle is just an estimate. I used steel protractor. I use protractor for this one. And then the resultant will be from the starting point towards the end point. So that is resultant. So how do we know the magnitude and direction of your resultant? Again, when you do head to tail method, you are going to use a ruler to measure the length of your arrow, or the magnitude of your vector, and the angle for your direction. So to measure the resultant, so that is around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, almost 12. So that's around 11.8. So that's around. So in this case, I'm just doing a centimeter for each grid line. So again, that is not really what the actual cm is, but I just represented it with cm. So that means every grid line on my background grid is 1 cm. So this is around 11 cm, and since we have a scale of 1 kilometer 1 cm, so this should just be equivalent to 11.8 kilometers. So the resultant, or the magnitude of the resultant vector, is 11.8 centimeter. And then to determine the angle, so I have here a protractor. So this one will start at the east, so that is 0, 10, around 70, and then so this one right here is 70, 71, 72, around 73. So the angle is 72 degrees, so north of east, or northern part of east. Next, so using parallelogram method, using the same example, so that will be this one. So again, the resultant will be measured using your ruler and your protractor. So next, we have another example. This is a plotting example, so we are not actually measuring the length or the magnitude and direction, but this is just how to do it, and all you have to do is to use ruler and protractor to measure the magnitude and direction of your resultant vector. So we have vector 1, 3.0 kilometers, 15 degrees south of west. Then we have 6.5 kilometers, 30 degrees south of east, then we have 5 kilometers east. So the resultant vector is always from the starting point to the end point. So that's the resultant. So again, to determine the resultant, you are going to measure using your ruler and your protractor for the angle. Analytical method. So this is the computation method. So the first one is component method. So this uses trigonometry to compute for the resultant vector. So to make it easier, so you will have to have your table. You have here the label for the first column, x for the second column, and y for the third column. So for vector 1, so in this is just an example. So you have vector 2, so we'll have it vector 2. So if our vector 2 is this blue arrow here, that is 7 kilometers 60 degrees north of east. Now we have to remember that this vector has an x component and a y component, because in component method you will have to separate the x and y component of every vector you have. For example, you have vector 1, you have x, certain x and a certain y, and vector 2 also you have a certain x and certain y. So you have to get the sum of the vectors, the sum of all x's and the sum of y's. So that will be your resultant x. That will be the sum of x and the sum of y. And then to determine the resultant, you're going to use Pythagorean theorem. Okay, so examples for computing Vx, or the x component of your vector. So you have here is Vx, and you are not given with Vx, you are given with the angle, and you are given with the resultant, not the resultant vector, but the vector itself, which is not, or which happens to be not on the axis. So in this case, this will be our hypotenuse, and this will be our adjacent to the angle. So we have adjacent and hypotenuse. So adjacent and hypotenuse. So we can use this formula cosine because it has adjacent and hypotenuse. So we have cosine theta adjacent over hypotenuse. Then we have cosine 60 degrees equals Vx, because our adjacent is Vx and our hypotenuse is around 7, that is given. And then rearranging the equation, we have Vx is equal to cosine 60 times 7. So if you want also to determine the y, if we want to know the y component, this side right here. So this side right here is opposite to the angle, and we are given with the hypotenuse. So opposite to the angle and hypotenuse. So we will use sine in our SOHCAHTOA. So sine theta equals opposite over hypotenuse, and we have sine 60 degrees equals, our opposite is the Vy, and then our hypotenuse is 7. So rearranging it will be 7 Vy equals sine 60 degrees times 7. Now the analytical method, or the second method for analytical method, is sine and cosine law. So here are the formulas for sine law. We have sine angle A, which is this angle, over side A. So this one is side A, and that is equal to sine angle B, this one is angle B, divided by side B. And we have sine angle C divided by side C. So all of those all of these terms are equal. And we also have cosine law. So the formula for cosine law is c squared, or if we want to know side C, so the formula is square root of a squared. So this one is side A, so square of A plus square of B minus 2 side AB cosine C. So that will be this angle. So again, the arrangement is, if we have side C, the opposite angle to that is angle C. You follow? So we'll have examples. So examples for component method. So assuming that these were not filled in yet. So if we have the given 5.0, again the same given as we have when we use graphical method, the head to tail or triangle method. So here is the drawing or the diagram. So how do we solve this one using component method? So basically, using component method, you will have to fill in all of this here to know the resultant. So again, for vector 1, so this is our vector 1, the 5 kilometer north. So if you observe, the vector is moving towards north. There is no movement towards sideways. So it's only moving upward. So meaning to say that the x-axis or the x values here is 0. And for our y value for vector 1, we have 5 kilometers. You follow? That's why you have 5 kilometers here. And then for this vector right here, so this one has x component and y component. So we are going to compute for the x component and the y component of our vector 2. So how do we do that? So again, using SOHCAHTOA, just like what we had a while ago. So to compute for the x component of vector 2, we have cosine 60 equals bx over v2. So cross multiply, we have bx is equal to cosine 60 degrees times 7 equals 3.5. And then for our y value, so sine 60 is equal to Vy over V2, so cross multiply, we have Vy is equal to sine 60 times 7, which is equivalent to 6.1. So we have now 3.5 for our V2x and 6.1 for our V2y. So you get the sum, you add 0 plus 3.5 is 3.5, and then we have 5.0 plus 6.1 is equal to 11.5. So how do we determine the resultant vector? So to determine the resultant vector, use Pythagorean theorem. So Pythagorean theorem is, formula is, I was not able to write, so that is c squared equals a squared plus b squared. So this x is our a and y is our b. So that is square root of 3.5 square plus 11.1 square. So the answer is around 11.5, or approximately, following the number of significant figure, that is around 12 kilometers. So how do we determine the angle using component method? So if we, so this is our resultant, Now, this resultant has x and y component. So the x and y component of this resultant is actually this 3.5 and 11.1. That is the sum of the all x and all y's. So the sum of x is around 3.5, which is this line right here, and the sum of y, which is 11.1, which is this length right here. So how do we compute for the angle? So we are interested with this angle right here. So we want to know the value of this angle. So we are given with 3.5 and 11.1. So 11.1 is opposite to the angle, and 3.5 is adjacent to the angle. So opposite and adjacent, so we have tangent. So tangent, that will be our formula in determining the angle. So tangent theta equals 11.1, the opposite, over 3.5, the adjacent. Then we get rid of tangent, so over tan, so cancel tan, so we have theta. Then since this one is 1 over tan, or if we raise tan to the numerator, that will be tangent inverse or tangent negative 1, then times 11.1 divided by 3.5. So the answer is 72 degrees north of east. Now north of east because this part right here, the last position with the student is on the northern part of east. So it's in the northern part of east. So our answer now is 12 kilometers, 72 degrees north of east. Now comparing it with our graphical method a while ago, so that was just the same. So it is around 11.8, I think, so more or less the same. So let us go back to that slide. So I think it's, so we have it here, 11.8 kilometers, 72 degrees north of east. So our answer was, or if we round this off, because this following correct number of significant figure, so it should be 12, then 73. So our answer for component method is 12, the same here, and 72 degrees. Now which one is accurate? Now component method is accurate because we have less measurement here, whereas in graphical method we are measuring, so there might be error in our measurement, whereas for this component method we are merely computing it, so there is no human error in this answer. So more or less this is more accurate than the graphical method. So how do we determine the angle? This one is for component method. Now we have sine and cosine law, so the same given. So the formula for, so we use cosine law to compute for the resultant vector. So this is the cosine law. So this is 6 squared equals a squared plus b squared minus 2ab cosine angle C. And then in terms of our diagram, if we follow our diagram, it will be r squared. So for c squared we have r squared, and then for a, this one will be a, this one will be b, and this one will be c. So we have r squared equals v1 squared plus v2 squared minus 2v1 v2 cosine r. So our angle is, since this one is side r, this will be our angle r. So we know that angle r is 60 degrees plus 90 degrees. It is our angle r. So our given is vector 1 is 5, vector 2 is 7, then our r is 150 degrees. So this is our formula. So we get rid of the square. So it will be r equals square root of v1 squared plus v2 squared minus 2v1 v2 cosine r. And then substituting values, we have 5.0 square plus 7.1 square, 7.0 square minus 2 times 5 times 7 times cosine 150 all over square root. So the answer is around 11.6 or approximately 12 kilometers. How do we determine the angle? So we will use sine law to compute for the angle. So this is the formula for sine law. Side A over sine angle A is equivalent to side B over sine angle B, and this is supposed to be C. So this one is side C is equivalent to side C over sine angle C. So in our convention, we have R divided by sine R, then B1 divided by sine B1, then B2 divided by sine B2. So again, you have to remember that this variable below are all angles, and this variable above are all sides of your triangle. So substituting values, so our R is 11.6, then over sine 150, and then we have V1, which is 7. No, V1 is not 7. V2, so this one is V2. So we are using this formula. We are using this formula, equate it with V2. You follow? So rearranging the equation, we have sine V2 is equivalent to sine 150 degrees times 7 divided by 11.6. So we now have V2 is equal to sine negative 1 times sine 150 degrees times 7 divided by 11.6. So the answer is 18 degrees. Now, that angle might say that is different from our component method, but that refers to this angle right here, the inner angle. So that is 18 degrees east of north. So if you want to measure this angle, so that will be 90 degrees minus 18. So that is around, this angle right here would be 72 degrees north of east. So they are just the same angle. It's just the complementary angle. So that is 12 kilometers, 18 degrees east of north. Thank you for listening. That will be all.